Hello and Namaste. From this session onwards, we are starting with the successive differentiation. So today's session we are giving for the introduction and few of the sample standard formulae, how to go about and how to prove those type of formulae from this particular session. So what exactly the successive differentiation? Successive differentiation is the process of differentiating a given function successively times, and results of such differentiation are called successive derivatives. Now for example here, so if you just look at the different notations, first derivative, second derivative, third derivative, nth derivative, so you have got different notations and different books are following the different notations. So first of all, this y1, y2, y3, yn, f dash of x, f double dash of x, f triple dash of x, and f to the power n x. dy upon dx, d square y upon dx square, d cube y upon dx cube, and so on till d to the power n y upon dx to the power n. Or few of the books are also following this as capital dy. So what is this capital D? Is nothing but d upon dx. So it's one and the same thing. So this particular operator d is getting operated on y, d square y, d cube y, and d to the power n y. So the higher order differential coefficients are the utmost importance in scientific and engineering applications. So let us go ahead and check this one function. Suppose for example we have got a function y is equals to sine of ax plus b, and we have to find out or generalize this formula. You can just say that we have to find out the nth derivative of this particular function y is equals to sine of ax plus b using the successive differentiation. Now differentiating both the sides with respect to x successively, we get y1 is equals to a into sine, differentiation of sine is cos ax plus b, and this a is coming out from here. This a is coming out from here and is giving us a cos of ax plus b. Now this function cos can be converted into sine using adding this pi by 2 in ax plus b. So we can rewrite this as a sine of ax plus b plus pi by 2. That is what we have got it as y1. Similarly, y2 is nothing but again one more a will come out of here. Sine differentiation is cos. So a square cos of ax plus b plus pi by 2. Now we don't want this cos again. We wanted to convert this cos into sine. Again we have to add one more pi by 2 in this particular function cos of ax plus b plus pi by 2 as an angle. So a square sine of ax plus b pi by 2 plus pi by 2 will gives us a square sine of ax plus b plus 2 times pi by 2. So let us keep this 2 over here as it is. So if we'll just check this out, it's 2 here, it's 2 here, and it's 2 here. So I'm just trying to give you the pattern, different patterns over here. Everybody please check. I'm just trying to give you the pattern here. So it's 1 over here, and it's 1 over here. Right, now let us go and find out the cube. So that is, you can say that the d cube upon dx cube, that is y3, which is a cube. Again one a will come out of from here to this a square getting added in the power. So it's a cube cos of ax plus b plus 2 times pi by 2 is equals to, now again we have to convert this cos into sine. That will gives us here a cube sine of ax plus b plus 2 pi by 2 plus pi by 2. That will gives us a cube sine of ax plus b 3 times pi by 2. So again you check this is 3 here, this 3 here, and this is the third differentiation of this function. So if we'll generalize the same way, if we'll go on doing it, this nth derivative till the nth derivative, you will get the things here like yn. So we have to write down the yn is equals to a to the power n sine of ax plus b plus n pi by 2. So this is what we got it as the nth derivative of this particular function. Now whenever we are going ahead with the successive differentiation, you have to understand the different patterns, how this different pattern has been getting followed by the constants and the other terms around it. So this is all about y is equals to sine of ax plus b. Now let us go ahead and just list it out, all these derivatives of nth differential coefficient of some standard formulae. First of all, y is equals to x to the power m is greater than 0, then yn is coming out to be m factorial upon m minus 1 factorial to the power x to the power m minus 1. Now again there is a small corollary based on this, that is if y is equals to x to the power n, yn is coming out to be n factorial. That's quite obvious from here. Then this y is equals to ax plus b to the power m is greater than 0, which is yn is coming out to be m factorial upon m minus 1 factorial into a to the power n into ax plus b to the power m minus n. So this is about the nth derivative of the function ax plus b to the power m. Similarly, we have got, and most of the time we are using this a lot, y is equals to 1 upon ax plus b, which is equals to, that nth derivative is coming out to be yn minus 1 to the power n and a to the power n factorial, a to the power n factorial upon ax plus b to the power n plus 1. So if you'll observe here, we are taking care of only a over here, we do not want any b over here. Similarly, it is happening the same way. So we are just taking care of the coefficient of x, the coefficient of the variable. Rest of the constant will be as it is coming out to be here. Then the next is y is equals to 1 upon ax plus b to the power 2 will gives us the same, almost same. Where is the change? The change is instead of n factorial, it is n plus 1 factorial, and in the denominator ax plus b to the power n plus 2 is the change between the this consecutive formulae. Then y is equals to log of ax plus b is equals to, this yn is, nth derivative is minus 1 to the power n a to the power n minus 1 factorial upon ax plus b to the power n. Same way there are few more, that is y is equals to e to the power mx, which is yn is x to the power m e to the power mx, a to the power mx as yn as m to the power n log of a to the power n a to the power mx. Same way sine of ax plus b, which we have done it here, so a to the power n sine of ax plus b to the power plus n pi by 2. Same is that with cos, same angle n pi by 2. Then we have got, if it is y equals to e to the power ax sine of bx plus c, yn is coming out to be r to the power n e to the power ax sine of bx plus c plus n theta. What is this r means? R is nothing but square root of a square plus b square, and theta is nothing but tan inverse of b by a. And if it is cos, the same thing will happen. Instead of sine, we have got a cos, and rest of the everything will remain the same for these two different formulae. I have purposely kept this particular slides over here rather than to give you in the PDF format, so that you can just go ahead and understand all of them. Based on all these standard formulae, we will be going ahead with a different set of questions in the upcoming sessions. Please stay tuned, stay connected with this. Thank you. Happy learning.